So this is an introduction to organic substances that is usually done before chapter 16 and 17, and it's just a review of some things you might or might not know about carbon-containing compounds, and it'll make it dangerous in the world of figuring out how these carbon-containing compounds exist in acidic and basic areas. So make sure you have a paper, pencil, notebook, ready to take some notes. So organic substances are composed of carbon. They have 4 bonds per carbon, and when in doubt, make sure that a carbon is bonded to a hydrogen to complete 4 bonds. They're named by prefixes. You've learned these prefixes: meth, eth, prop, bute, penthex, hep, doc, non-dec. That tells you the number of carbons in the substance. Additional groups can be added on or into a chain of carbons, and these different groups or ways that they are bonded in the chain give them the suffix. And so if they're composed of only single bonds, they have an ane ending. They're called alkanes. Double bonds, they have an ene ending. They're called alkenes. And if they have a triple bond in them, they're called alkynes and have a yne ending. So here's 3 examples. Here's ethane, C, 2 carbons because it's the prefix eth, and then it would have 6 hydrogens around it, H, 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 and H, and then H, and it fits the normal format of C to the X, H to the 2X plus 2. That's the normal ANE or alkane format. Ethene would have a double bond, so it would have 2 carbons, that are double bonded together, and then to complete 4 bonds around each carbon, each would only have 2 hydrogens. So this fits the format C to the X, H to the 2X. That's the way that alkenes fit all the time. And then ethyne, this would have 2 carbons, and it would have a triple bond. This would have 1 more hydrogen on each one, and so it would fit the format C to the X, H to the 2X minus 2 actually, and so this would have two hydrogens with it as well. So that's the 3 different main bonded groups depending on their types of single, double, or triple bonds. So here's some more on how to identify and draw these particular structures. First of all, remember that carbon forms 4 bonds. Second of all, that the prefixes tell you the number of carbons. The suffixes can be different, and I just told you 3 of them based on single, double, and triple bonds. But the suffixes can also tell you what's attached to each one of the structures. There's a suffix that's in amine, A-M-I-N-E. There's one that is in oic acid, and of course that's an acid. And we'll learn about both these kinds in chapter 16 and 17. There's ones that end in OL. These are alcohols that you've probably learned. And then there's examples of ones like ene, ine, and ane as well. So these tell you the substituent groups, or the things that are added onto the chain, or the way that the chain is made. I'm going to do lots of examples of these particular ones, especially the ones that are acids, and these turn out to be organic bases. Just to give you an idea of when you encounter them, you'll feel a little bit more comfortable seeing them. So one thing that a lot of times happens in the book is that they'll draw a stick model, which is a quick way to draw these carbon-containing compounds. And so they'll just draw a line like this, and they assume that you know at the end of each one of these lines there's a carbon, and the carbon is bonded to 4 things. And if there's just one line, that means that it's just a carbon bonded to a carbon. That's what this represents. And each carbon then has 4 bonds around it, and each one of these carbons would then be saturated with hydrogens like this, so it would have 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds. It's just assumed that you know it. If there was like 2 lines like this, it would assume that you know that there's a double bond there, and this would be ethene. This would be another way to draw that, and so this structure could be symbolized by this. How about ethyne? Well, 3 lines like that would technically mean that there's a carbon here and a carbon here, and it would each have 1 hydrogen attached to it. All right, let's focus on these suffixes right now. The OL suffix means that it is an alcohol, and an alcohol means that it contains an OH group. And the OH group would be attached to a carbon somewhere in the structure. So here's an example. Here's ethanol. So this is just like ethane, except one of the hydrogens is replaced with an OH group right here. So this would be called ethanol. Or you could draw it like this. Sometimes they'll condense this part of the structure. Instead of drawing all the H's around here like this in the Lewis electron dot structure, then what they'll do is they'll draw this as CH3 and then put a C. Sometimes they'll put CH2 here, and then they'll put an O and an H like this. And notice in this particular form of the structure, they put the unshared pairs of electrons on the oxygen, which of course is important because we know that that makes it be a bent shape, and this having a 104.5 degree bond angle as well. Or here's the stick model. Here's 1, 2 carbons, and then we're connected to an OH like this. This is like the shorthand way of drawing ethanol. And it's assumed that there's a carbon right here with 3 hydrogens around it. And then it's assumed that right in here there's a carbon with 2 hydrogens around it, because each carbon has to have 4 bonds. All right, let's talk about the second group right here, the oic acids. So here is the structure that needs to exist for it to be what's called an organic or a carboxylic acid. You have to have a carbon connected to a double bond connected to an OH. So it has an alcohol portion in it, but the carbon that's connected to the alcohol portion now has a double bonded O also connected to it. And then this is connected to some carbon chain right here. It could just end right here, and this could be an H, and then that would have the prefix meth because there's only 1 carbon in there, and so that would be called methanoic acid, because it would have the oic acid at the end and only 1 carbon in it. Let's do some examples of that with the oic acid suffix. On the next page, we'll actually do a number of them. But let's talk about amines, this group right here, before we give lots of examples. Amines turn out to be bases many times for us in the chapter 16 and 17. And amine groups have an amine suffix, and they have a carbon connected to a nitrogen that has an unshared pair of electrons, and then the nitrogen has 2 H's on it. This amine group right here acts basic because this pair of electrons right here is really attractive to positive things. And if you remember way back from chapter 4, we talked about how acids are proton donors, and so they're very attractive to the H pluses. Anyway, let's do some examples of each one of these as being organic substances and how to draw them so you can become a little more comfortable with them before you get deeply into how they act as acids or bases. So first of all, here's an example of ethanoic acid. So ethanoic acid means that it has eth as a prefix, so 2 carbons. And then when it has 2 carbons, it has to have a double bonded O, just like here. And then it has to have an OH connected to it as well right here. And then you draw the unshared pairs of electrons on here, the unshared pairs of electrons on here, and then of course completing up 4 bonds. So this carbon would have 4 bonds around it as well. Shorthand way to draw this would just be a stick, double bonded O, OH. So it assumes that this is a carbon, it assumes that this is a carbon, and it is completed with 4 bonds around it. All right, how about an amine? Well, here's ethylamine. So ethyl, once again, means that there's 2 carbons in it, but then it's going to have this amine group attached to it. So we're going to have 2 carbons, and then there's going to be the NH2 group attached to it right here. And of course, you should know that there are hydrogens attached to the carbon right here to make sure that it always has 4 bonds. Or a shorthand way of drawing this would be the stick model. 2 carbons, and then it's attached to the NH2 group right here. So get used to both ways that it's drawn, and of course the shorthand way is going to be used a lot because then you understand that this stick line method just means there's a C with 4 bonds around it. Let's go the other way, some structures and some names. So here's a structure And let's see if we can figure out what its name is. This is a stick structure again, and each bend right here represents a carbon. So 1, 2, 3, 4 carbons in it. So the prefix for 4 is bute or butane. And then since it's got a double bonded OH, you learn that a double bonded OH means it's a carboxylic acid, and so it has oic acid at the end of it for a suffix. So this would be called butanoic acid. And then let's try this one. This one's written a little bit strange, and it has a weird thing on the end right here. We notice that it has an NH2 on it, and you learned that an NH2 is an amine, and so it's going to have an amine suffix. But let's count the carbons. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. 5 means the prefix pent, and so we would call it pentylamine. You usually put YL on it, indicating this is a pentyl group, and then attached to it is the amine group, which is the NH2. Now, could I draw it as a stick structure? Sure, certainly. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then attached to this, I'd put the NH2 group, which is usually drawn like this, so then you can illustrate, hey, there's my unshared pair of electrons, which is the important part of the whole structure. Let's try this one. This one looks scary and long, but you see it's got a C double bond OH in it, which lets you know, oh, this is an oic acid, right? A carboxylic acid, one of these types of things. Okay, let's count up the carbons so we know the prefix. 1, 2, 3, 4, 5, 6. 6 carbons in the chain. Prefix for that would be hex, and then we put anoic acid at the end of it. So this would just be called hexanoic acid. How about this one? This one's got the chain written in a stick format. 1, 2, 3, 4, 5. 5 carbons, and then it's connected to an OH. If you forgot what an OH group means, remember that's an alcohol, and it ends in OL. So 1, 2, 3, 4, 5. The prefix would be pent. And then we'd put ol at the end of it, pentanol, because it's a 5-carbon chain acid. How about this last one right here? This one's a stick model. We just have 1 carbon here and then an NH2. Prefix for 1 carbon is meth, and then it's a methyl group connected to an amine, so we'd call it methylamine. I hope this gives you a good enough introduction to just some things that are organic structures, and then especially when we encounter the groups that are acids and the groups that are bases in chapter 16 and 17, you'll feel much more comfortable. Good luck with your organic structures.